All right, so welcome again, everyone, to the LoRaWAN crash course. Let's get started by defining what is the Things Network. The Things Network is a community that has this description: a global community building open source to operate crowdsourced network for the Internet of Things. It started in 2015, and by now it's present in basically every country in the world. There are tons of gateways and developers around the world using it. But this basically means that this is a global free and open Wi-Fi for sensors, to put simple. In Switzerland, TTN, the Things Network, is composed by a large community that it's present in the Slack that you're all in, and also in the IoT meetup group of Zurich. But additionally, by an association called Open Network Infrastructure Association, which is helping the community do some things that require a legal entity. For instance, this hackathon is organized by the association. But like, what are we doing exactly? We're trying to provide coverage for an entire city, but how do you really provide coverage for a whole city, right? And not being a telco. This is the current map of Zurich. All this blue that you see there is gateways that are installed by the community members. None of these things is operated by a telecom operator or nothing like that. This is just regular people installing gateways at their homes and extending the network. So this basically means that you can go out with a sensor today and use the network, and it works. For connected to the internet for free, no strings attached. One second. There are three main things that make this possible that I want to touch on today. One is technology. The other one is community. And the last one, but perhaps the most important part, is openness. They're all interconnected in a way. Let's start with the technological part. Like what is this for you? So I think, like, I know many in this group, and many probably they know all these slides even, and they know what LoRaWAN is. But for those who don't, LoRaWAN is the LoRa part in the LoRaWAN term means long range, and it's a radio modulation technique. And LoRaWAN is a protocol that sits on top of it. It's a MAC, like Media Access Control Protocol, for WAN networks, for wide array networks, that roughly corresponds to the OC layers 2 and 3. But these are all details. In the end, what LoRaWAN does is it links sensors or nodes from one end to an application backend. And what really is the LoRaWAN domain is the connection between sensor nodes and the IP world. So because LoRa is not IP addressable, the devices don't have IP addresses. They just communicate with this modulation. So there needs to be something that converts these messages back and forth into the internet that we all know. The marketing pitch of LoRaWAN is these 3 10s that at the beginning I thought it was all bullshit, but after a while of testing, it's not too far from the truth. The most impressive one is that it has a very, very, very long range in the kilometers within an urban city. So in a city like Zurich, that is, or any typical European city that are not super dense, you can get 10 kilometers of range to an antenna, to a gateway. The price, it's still more or less like that. It's kind of $10 per node or per modem. We were hoping this would go down a few years ago. It didn't really happen. I don't know why, but yeah, it's more or less still, if you're buying it individually, it's still more or less that price. And the 10 years battery life obviously depends a lot in what you are doing with the sensor. But as a rough estimate, you can get really long battery life with LoRaWAN. The range part is what is really interesting, at least at the beginning when you start with LoRaWAN, because these are some measurements. These are real measurements. The map I showed before was an estimated coverage, with showing some kilometers around each gateway. But this is real measured points that we did in Zurich long ago. And we see easily 2, 3, 5 kilometers in a city like this one. And this is in cities. When you go out, you can easily go into like double digit of kilometers. There is another one. And then, of course, you can get insanely long ranges. There was a video by some of you might know, a YouTuber from Basel. He's called Andreas Spies, mostly known as the guy with the sixth accent. And he did a test driving north from his location, and he managed to connect ground to ground, so not ground to air, 201 kilometers to a station in Switzerland, which is insane. And it can even get crazier if you go ground to air or air to ground. They did, and I think this is already outdated. They did like 700 kilometers from the ground to a helium balloon at some point. This map shows one point, I think, and connecting to all these gateways around the Netherlands. The other aspect is that it's very low cost. Besides the node transceiver, the node, like the modem being rather cheap, the gateways are also very cheap. Nowadays, you can get these indoor gateways for less than 100 francs. These are the kind of gateways that you have in the hardware kit. But more important than that is that operating the network has almost no cost. So there is a little capital expenditure if you want to use this, but there is almost no operational expenditure because everything is open source, the whole stack. Plus, it works on unlicensed bands or bands that don't have any royalties. You don't need to pay license to use these radio bands. Yeah, this is the version 2 of the stack of the Things network. Now there's a version 3. The community network is not yet migrated to it, but it will at some point. Works in roughly 3 different frequencies around the world. In Europe, it works in 868. In Asia, works in 433, and in mostly the whole Americas and also Australia. It works in 915. That means that you can, if your node supports switching across these frequencies, which many at least do support switching between 868 and 915, you get access to.
Yeah, but you want to connect this?
Yes, I want to connect this.
No, it's Bluetooth.
You're not. Sorry?
You're not.
I'm not.
You can do.
So that means that you can get connection to the internet without roaming around the world almost. Oops. Then there is the low power aspect. There are three power profiles in LoRaWAN. They are called classes. So class A devices, class B devices, and class C. Class A are the ones that are like supposedly up to 10 years. They have a very specific protocol. They are not receiving all the time. They cannot receive messages all the time. So they're not good for actuators in general. They need to send a message to the network in order to receive after that. So it's only initiated by the sensor that you can get connection to you can get feedback back to the device. Class B is time synchronized. That means like it schedules windows in which it will receive. It's currently not really supported because it needs precise time synchronization. And class C is for mains operated devices that actually are not on batteries, and they are always in receive mode. An overview of where LoRa sits in the whole ecosystem of different communication technologies would be this one. In the horizontal axis, you have the range. In the vertical one, you have the data rate, and here you start seeing which are the trade-offs for this technology, right? So LoRa is roughly here, and you have things like Zigbee that would get similar data rate, but much shorter range. BLE is here. Like Bluetooth would get you faster data rates, but much less range. Then you have Wi-Fi over here. You have the cellular technologies. Some of them are like potentially what will be 5G for IoT. But some of these things are available now. The difference here is clearly that these technologies that the telecom operators operate, they work in license spectrum, so they need to pay huge license costs to use it, which are transferred to you somehow, and then you have to pay to access these things. And all the other ones are running on unlicensed spectrum, so you don't need to pay. Like your Wi-Fi, right? You don't need to pay anyone to install your own router. Okay, but what are the limitations? Because so far we've been talking mostly about nice things about LoRa, but there are clearly things that it cannot do. One thing is the bandwidth is really, you cannot stream things. You can definitely not stream a video. You can barely send a picture if it's, I think you can't actually. The size of payload is very limited. So each message can have a maximum of 222 bytes in it. And if you're using that, you might end up having fragmentation. So 51 bytes is the safe limit, in fact. That's 51 bytes per message only. And then there are regulatory limits. Those are depending on the region that you are. But in Europe, the limit is based on duty cycle, and it's set to 1% on most of the bands that LoRaWAN uses. 1% of duty cycle literally means that in any time window that you take, your device should not be sending anything, should be silent for 99% of the time. So you're only allowed to send 1% of the time. So you have to be very efficient when you send things. The more inefficient that you are, the less that you can send. If you send huge messages, you will consume your duty cycle very quickly. If you have very bad connection, so if your gateway is really far away and you need to send using the maximum spreading factor, it's called an option in which the message will take a larger piece of the airtime, making sure that they arrive, but also paying the price of consuming a lot of duty cycle, basically.
Gonzalo,
Yes.
a short question from Dennis. I think it's not controlled, right? So if anyone would like to send more, he could, but he shouldn't.
Yes, that is very true. Yeah.
Okay.
Some modules have some kind of checks, but you reset them and that's it. Almost all the modules have an option to bypass this filter. The module that we're using in the hackathon has something called emergency TX, which is bypassing all this. But yes, none of the modules, I think, has permanent memory of how much you sent. So none of them enforces this completely. And besides the legal, the technical aspect, no one actually enforces it from the legal perspective. We've talked to Bacom a few times, the telecommunication agency in Switzerland, and we talked to them when we noticed that some people were clearly violating this, for example. And they don't do anything. They basically say, yes, unless unless we have a huge reason to go after this person, we will not. So there is such a thing as the radio police that can do it, but they don't for these things.
Maybe another question. Often when you play around, then you probably do much more than the duty cycle or so. And I wondered if there's some kind of, I think it's difficult, but some kind of a testing network or something like that.
No, there is no testing network per se, but if you're developing, in the end, it's about the duty cycle is to prevent the spectrum from being cluttered.
Yeah.
So if you're in your home developing with a gateway that is close to you, and you use your device when you're in testing, you use a very efficient spreading factor that also implicitly means or implies that it won't go far. Yeah. So you're not really polluting anything if you're indoors in that sense.
Okay, understood. Thanks.
So it's kind of fair game in a way. Yeah. Sorry. And speaking about fair game, on top of the regulatory limits, the Things Network has a fair usage policy, which is also not enforced. But if you blatantly violate it, maybe they will email you. But and that the fair usage policy limits how much you can send in terms of seconds of the airtime. That is 30 seconds of airtime per day, which is a lot because every message can be sent very quickly. But it severely limits the downlinks. So downlinks are the messages that you get on your sensor. That also includes confirmations. So this basically means that confirmed messages are a no-go, and actuators are not really a great option. So you can get some feedback, but it's not really the best technology for that. But for uplinks, it's pretty good. So sending stuff from sensors to the network, this works really well. But one of the things that sets LoRaWAN apart from the other technologies, now it's been a few years that LoRaWAN is here, and it's relatively clear that it already won against other competitors that were at the beginning, like Weightless and this other like Dash, other protocols that were starting more or less at the same time. None of those survived. LoRaWAN is still very widely used and very successful. Perhaps the only clear competitor to LoRaWAN are the the protocols that go into the license spectrum, because they are in some regards, for some companies in particular, it's better to have quality of service guarantees and these sort of things that on a free license, on an unlicensed spectrum, it cannot be really guaranteed. But what sets really LoRaWAN apart is not only the technology, it's one of the community. That's the what actually enabled the growth that it has now. In Zurich, we started in 2000, like September 2015, at the meetup, back in the times where we could actually meet, remember, and have beers together. So I proposed back then if there was interest to start building this network. We had the guy from Amsterdam, the initiator of the global community. We had him on Skype, and everyone was very positive. So we started meeting up a bit more and playing with these new toys. And at some point, we bought some devices, some test devices. The guys from Decent Lab, which have always been a huge help in everything that we've been doing, they helped us install or prepare these gateways to be installed outdoors. And so we set these things on houses of friends and in downtown Zurich. And what happened there is that from since with 2 gateways, we were already covering a large portion of the city because of the reach that this technology has. So once the network was there, people started doing a lot of things with it, playing with it, and creating trackers and whatnot. But the fact that the network existed changed the perception of what could be done with it. It's kind of like there's an inertia of doing things, and once this thing was in place, everyone was very happy to use it, which we've seen later on in different communities, that communities that don't have access to, don't have the same socioeconomic position that Switzerland has, they have much harder time getting started because it's just it's a lot of cost to get this thing going if you don't live in a country like Switzerland, basically. And then the last and perhaps the most important thing that makes all these things work is the openness. And openness and trust, I would say, because we need to build trust in an open network, right? This is the main question that drives community growth. Can we trust an open network as a user of this thing? Is it even possible? Why, if I'm a user of this, why should I trust that the person that is running gateways will not just shut down their gateways and then I'm screwed? Or how can I trust this thing? And the key to build trust has already been demonstrated in other things. It's basically open source and open standards. The world now, you definitely realize the world runs on open source. 20 years ago, nobody had this point of view, perhaps, or few had them. In general, if you would go to a company, the safer option, the right thing to do, in quotes, inside a company was always going the commercial route, buying from expensive vendors or Oracle, these things, proprietary software, Windows, etc. Nowadays, this is flipped in many regards. The internet is run by open source. Who has seen a Microsoft server in years in the wild? It's like almost non-existent. Even Microsoft is running Linux on your computers now with this Windows subsystem for Linux. So open source became the default option. Open source basically won that. Another question is if we can transfer these concepts to an open network. How did open source won this? And can we do the same thing in the networking space? And some things actually have an answer already, and they are similar to the answers provided by the open source history. Is, for example, if you confronted with the question of whether you can trust that the gateway won't be shut down, redundancy is the answer to that. And it's not like you have to trust a single person that they will not shut down the gateway or they will not move to another location or whatever. It's just that if there's enough gateways, it doesn't really matter anymore if people turn them off or on. In the map that we saw at the beginning from Zurich, the blue area is so direct because there are lots of gateways very, very densely installed. So it doesn't really matter if someone shuts down one gateway, someone else will pick up that message. The next point is very important. Can I trust that sensitive information will stay private? And here you don't have to trust. You don't have to trust the judgment of men, basically, because you can trust the law of physics. The protocol is encrypted end to end, and you don't have to trust anyone. If someone doesn't have the key, it's impossible to decrypt this. Okay, impossible is always a tricky word to say, but at least with current technology, it's very, very hard or close to impossible to decrypt communication that has been encrypted end to end properly. And then the almost last question is, can we trust that the backend will be up and running? This is, for instance, the gateways that are now in the hardware kits. Those are the product of a commercial endeavor that failed, actually it succeeded, but it succeeded too much, and it doesn't exist anymore. This company was so successful that it was acquired by another company, by Semtech. So the service that was provided went away, and the devices basically became bricks. So we could reconfigure them to use the Things network, but yeah, this is an example of if you stay afloat forever. And here, decentralization of the network clearly helps a lot, if not solves the problem completely. In Switzerland, in the association, we run a separate backend that is connected to the main one. So it all works as the same transparent network. But it's decentralized. If the Amsterdam central, let's say, goes down tomorrow or decides to shut down the whole thing, we can continue running this one. If we decide to shut down tomorrow, or if we all die tomorrow, anyone can fork this and run another backend and keep it up and running. And this is because everything is based on open source and open standards. So the only way to trust that something will be around in a few years' time, the only way to be digitally sustainable in that sense, and is based on open source and open standards. There is a conference that happened at the same time that we kickstarted last week, that is called DINACON. If you haven't been there, join the next year. It's very nice. They always talk about digital sustainability in this, from this vision, right? How can you ensure that the technologies that we use today will be usable in some years? Okay. Now let's start connecting things. Let's do something a bit more hands-on. So I'm going to start with a quick overview of how to connect your gateway. I guess most of you already did, but anyway. The connecting things, sorry, if I go here, connecting these things means basically going from the device through a gateway, through the things network, which roughly contains these three components, which we don't really care about, up to an application. And this would be like an application server, not an app on your phone, right? Connecting a gateway is relatively easy. Gateways are devices that are super simple, and they talk to one component called router, not to be confused with a Wi-Fi router. This router is a component in the Things Network backend. And yeah, they're simple forwarders. They listen to the frequencies of LoRaWAN, or the frequency of LoRaWAN, and they just send upstream to the router every package they get. Absolutely everything. They don't filter by network, by operator, nothing. There can be multiple LoRaWAN networks in the same space. All the gateways in the area will pick up messages and forward it to their data, to their network servers. One thing that sometimes people confuse is how the gateways connect to each other, and they don't talk to each other at all. They form a star of stars kind of topology. So a gateway is connected to the router via a piece of software called packet forwarder that talks through a, well, these are little details, but they talk to a bridge that will talk to the router, because there are multiple protocols for the gateways to talk to the network server, to the router. The simplest one is just a JSON packet that is sent over UDP. So these are the simplest, sometimes referred to as the legacy packet forwarder, which is the case for the gateway that we have in the kit, and many others actually. But there are different protocols. There's been a few experiments along the way, and now the newest and most apparently best protocol for the future is called Basic Station, which is developed by Semtech, if I'm not mistaken. Yeah, but then whatever, there are bridges, and then any kind of gateway talks to the router through these bridges. Since the gateways don't talk to each other at all, that means that if I have a sensor here, and the sensor sends a message, and these three gateways pick up the message, all three of them will send it to the network. So the network server does deduplication, or to be more precise, there's another component. It's not the network server, but there is something in the network that detects duplicates, and removes them. So in your application, you don't see that. There are lots of different kinds of gateways. There's outdoor gateways that look bulky like this one. This is a nice gateway that is built in Switzerland, actually, also outdoors, relatively cheap. But you also have gateways that you can build with a Raspberry Pi and a little shield. So it's easy to get started. At the beginning, this was the preferred option because it was the cheapest, but now there are indoor gateways that are even cheaper. So it's almost better to get the indoor ones. The one we have in the kit is this one. The way to plug it is you just connect an Ethernet cable on one of the black ports. You connect the power supply, and that's it. You plug it to your router, and that's it. They do have more features. A few people ask if they could use Wi-Fi to connect, if they could. Yeah. Those features are actually possible, but we disable them all. If you are really into hacking this device, it's possible to get SSH access to it. So you could try to play with this. But the disclaimer is that this is completely undocumented. We don't have documentation, there's no support. The company that produced this the company that produces this was acquired by Semtech. So nobody can support you if you go that route, basically. I will make a quick stop here and ask if there are questions or anything before I continue.
Yes, I have a question again. Sorry. You mentioned Semtech before. Do you know how they are or how they think about openness? Or could it be that they suddenly say, oh, now you have to pay, and then we are dependent on them?
There is one bit, they make money from IP. This is clear. So LoRaWAN is very open, and this is pushed by Semtech, except one thing. The intellectual property of the thing that actually does the modulation down there, the module, this is protected, and this is what costs money. It's none of the protocols available is completely open in that sense. Some people manage to reverse engineer the thing, and there is an SDR module, I think. So you can kind of build software-defined radio-based LoRaWAN stuff, which wouldn't be legal technically, I think. But yeah, in the trade-offs that you can have in this space, this is relatively okay. They promote openness up to the point in which it gets to the hardware IP kind of, or that modulation. So they are personally responsible for opening up the protocol. The protocol is driven by an open alliance called the LoRa Alliance. It's independent. One of the, for example, in the board of the alliance, people like Johan Stocking from the Things Network sits and decides on how to drive the protocol forward. So it's relatively safe to bet on this technology because it has enough openness to trust it.
Okay, thank you.
Okay, if there are more questions, just say so. If not, I will continue. Okay. Once you plug your gateway, you can not do anything about it, and that's it. It will work, but you can also claim it in the Things Network console. Claiming it means you go to the console website and you say, this is my gateway, this is the ID that I have, and it will appear in there, and then you can see the traffic directly there. You can see the encrypted traffic because the protocol is encrypted end-to-end, as I said, so you cannot sniff the details of the traffic, you cannot see the payload, but you can see traffic in and out packets. There are two ways of accessing the console. You can go to the Things Network website and then go to the links on the navigation bar and get to the console. But as I mentioned at some point before, in Switzerland we run a Swiss instance of the backend. The backend is accessible. The Swiss backend is accessible on this URL that I heard has won the award for longest URL in the planet. So we created a short link. So if you go to u.nu/ttn, you get to the same thing, and it's a bit shorter to type. So I can go there, but this is it. Let me. So if I go to u.nu/ttn, I will be redirected to the console. This is the console. And here you have applications and gateways. These are the two views that you can have on the stack. If you go to gateways, if you want to claim your gateway, you say register gateway. And here you have to enter some ID, whatever. No, sorry. You have to tick this thing first. We are using the legacy packet forwarder. So you have to tick this thing. And in that case, what you need to type here is the identifier that you have in the gateway. This is printed in the label of the gateway, both in the back, also on the back. It looks like this. So it looks like these pairs of digits. They are in hexadecimal, but they are too short. So each of these pairs is a byte, right? And the thing that is printed on your device has 6 pairs, so 12 letters or 12 digits, and you need to add this 4 in here. So you need to inject FFFE in between, right in between. So 3 pairs in front, 3 pairs in the back. Sorry, I wasn't watching the chat. I just see now that there are lots of questions there. Yeah, if you go there, you will need to log in one time. Login is centralized right now. So if you go to u.nu/ttn and you're directed first to the Swiss console, but then you're not logged in, you will be redirected to accounts.thingsnetwork.org. You log in with the same user, and then you will be redirected back to the Swiss backend. Thomas, you asked me if I can zoom in to this part, or did I miss the message and it was before? Or you mean this part? Okay. So like this, right? Cool. So yeah, you enter here the ID of your gateway. This, but this is not mine. This is just an example. Description, and then you can, these things you can select, but right now they will have no effect. This is only for information purposes. You should select Europe 868 megahertz, and your gateways are actually connected to the European router. So it is this one, Ttn router EU. This is the router that is operated by the Things Network Foundation in Amsterdam, not the Swiss one. If you want the Swiss one, you select this one, switch router, which is operated by switch.ch, the ISP for academic institutions in Switzerland. But right now, the gateway that you have does not update based on this. So this is for newer gateways that use newer protocols. And then you can locate it wherever it is. This is only, again, for information purposes. Select if it's indoor or outdoors, register it, and that's it. So once you have it registered, it will look like well, like any of this. And then you'd have information about when it was last seen, and you have things like traffic here, where you can see the traffic that is going through. The traffic is encrypted, so you cannot really see the payload, but you see that something is going on. This is good when you're debugging. All right. Questions so far? Yeah, Ttn router EU. If you change it, I'm replying to a chat question that says if you have to select Ttn router EU, if you change it, it will not make any difference on this router, on this gateway. This only makes a difference if you have, for example, well, some of the gateways that run the basic station protocol, but that's it. For now, just, well, it's kind of irrelevant. Select whatever you want. Select the one that you intend to use, and then maybe at some point it will start being used. Okay. Now, let's go to connecting an application. We will see first what is the, once you are ready to connect to the Things network, you need to create an application, and an application is not has nothing to do with an app, or has nothing to do even with an application server at this point. An application is the information is not public. No, the information is private to you. Nothing that goes through the network is openly accessible by default. If you want to make data accessible via open data, you can, of course. You can take that data and information about the gateway. The information about the gateway is public, yes. So the details about whether the gateway is, in which location it is, and the antenna type, this is information that that is public. How many? Can you, Francesca, can you unmute and just ask it? I didn't get it.
Sorry, I have to speak really.
Okay.
I mean, how I see where you were connected in the list. So is public this information or not? When you were? Yes, before?
You mean here, I guess.
Exactly. The location, I mean.
Yeah, this is public. This is like saying I am installing a gateway, an antenna, in this location.
Okay.
This is good. Yeah, it's the gateway location. It's not the sensor's location. So this is
Okay.
useful for example, if you're mapping, if you're creating maps. It's generally useful for the community to see where gateways are available.
Okay.
But you can, of course, as Thomas is saying in the chat, you can provide false coordinates, which will be really nasty because then you will get you will appear in the map as having either amazing range or terrible one, and you won't. Yeah, it will just mess up things. You can leave them out as well. You can put them in the null island as well. The null island is 0000 things. And you can also check if gateways are, which gateways are online. There is a very nice project called Ttn Mapper. This is taking all the gateways available, and it reports whether they are online or not. Also reports if there were measurements done in the that access that gateway. So here you can see effective coverage, right? And this is, it's always very nice to see Switzerland because all these things means that there were connections that were made, right? So there was someone that connected for example, for this gateway, someone connected from here because you see a ray coming here, someone connected from here. These measurements are not like random sensors that were tracked. These are specific sensors that are designed to create this map. And this is people that contribute to the map by walking around the city or biking around the city or putting these things into cars or whatever and tracking, okay, this place has coverage for TTN. The ray view is very hard to follow in Switzerland, but this one is much nicer. Here you can see tracking that was done and where. So these are points in which, so green means very good reception, red means not so good, but red means bad, I think. These are points in which someone was walking around with a tracker device, intentionally contributing to this map, not being tracked, but intentionally helping this community. And here you see the gateways that are online right now. And yeah, there's plenty. Of course, in the middle of the land, there are some places that don't have many. But the more isolated that you are, the easier it is to cover large portions of the territory. Because if you put one gateway on top of a mountain in the middle of the Alps, then you cover the entire valleys around it. And that's it. Yeah, Thomas is pointing to a kind of fake funny community. The Things Network has all these communities organized for the different cities, and there is one that is called the Null Island that collects all the gateways that are in 00 latitude, longitude. So that's the famous Null Island. But now there are only two. I don't know. People are either very well behaved or I don't know. Okay. The gateways that are in the kit need to be connected with a cable to your router. In principle, they are able to. I'm replying to a question in the chat. In principle, they are able to connect to Wi-Fi. They are also capable of becoming a Wi-Fi router and then connecting via their blue one port to your internet provider. But these features are disabled for the reasons I mentioned before. The device has no support from the company that produced it. So Yeah. We just made it easy to use, but further configuration is basically up to your hacking skills. If needed, we can provide access to the device via SSH. And you don't need any port forwarding because this is an outgoing connection. You just connect the cable. The device will initiate an outgoing connection to the Things network router. So the attack vector is very small. That's why it's also safe for us to recommend people to use this thing. There's almost no way that this can be a security issue because it doesn't open any ports, it doesn't do anything. It's just outgoing UDP connection to the outdoor. Francesca, could be interesting when it's really difficult to find a connection. You mean a wired connection to use Wi-Fi? Yes, of course. But for that, I would say, like, if for that, there are other devices like this one. This is the indoors gateway from the Things network. It's like 80, 90 francs, and this connects to your Wi-Fi, and it's just easier for that. Okay. So I hope I answered everything that was asked. Thomas, you asked if the EUI has to be extended with if FFFE. Yeah, that's right. And I think now I answered everything. Okay. True, Oleg is saying that there's a gateways channel on Slack where there are tips for configuration and connection. Good, let's continue. You can keep throwing questions into the chat. An application is just a container for devices. So it's a really simple thing to create one. You just need to say, I want an application. There's one important bit to keep in mind here. And like the reason of existence for applications is that you need a key. You need multiple keys to connect your device in the end. You need 3 different keys. Those 3 different keys will be exchanged by the handshake, by the joint protocol, to generate new derived keys that are the encryptions, the basis of the encryption that runs in your session. But you need 3 keys. You need a device key that it's actually called device EUI. You need an application EUI. I don't remember what EUI stands for, something like whatever unique identifier or something like that. And you need an application key. So this is the main reason for creating an application. You need this application identifier, and the application identifier is generated by the Things network in this case. Otherwise, you would need to buy some chunk in the space of identifiers that belongs to, I don't know who, the IEEE or something like that. That basically allocates that these things are still unique. It's like the MAC addresses, right? If you can always spoof them if you want, but ideally you use things that are derived from the main pool and the allocation processes for these things. So let's go and see in the website how it is to add an application. If you can already start doing this for you, maybe you already did it, but it would be good because we will use it. You go to, when you're in the console, you need to go to applications. And then in applications, well, I have a lot of them, but you can add a new application. And this is where you, first you give it an ID. This is just whatever ID that you like. It's just for your own purposes. Super cool app. This, I think doesn't, yeah, can it have? No. It's like on, it's identifier like, so only lower cases and dashes and these sort of things. And then you will get, if you click an application, you will get one of these things assigned. You also need to select the handler. The handler, it basically means selecting this bit. I didn't want to get too much into the details of what is inside the Things Network backend, because at some point they should be more like a black box. But if you care about, for instance, data locality, if you care about the fact that data should stay in country, you know that there are legal regulations of for how to manage data when the data leaves the borders of this country or any country in general. So if you care about these things, you will care about the handler. The handler means it's the exit point of the data. So data starts from the device, it will go to the gateway. The gateway will send the data to the router. We saw that we selected the router at some point, and you can select the Swiss router, which is called switch router. So if your application also uses the switch router, the switch handler, sorry, it means that the data will not leave Switzerland. The data will go through the entire instance of the Things Network backend that runs in Switzerland, operated by Switch, and it will leave and go to your application handler or your application server without ever leaving the country in principle. Yeah. So once you do that, and I did it here for the sample application that I'm going to use, you will see something like this. This is the UI that has been assigned for this application. There's a bunch of things that I'm not going to touch upon, like you can configure collaborators, so you can have the same application shared between multiple people. This security thing works more or less like GitHub, in which you can grant access in a somewhat similar style. But then we care about devices. We've been talking about a bunch of things so far, but we didn't get to the devices, and we want to connect devices. No, we don't want to play with this UI. So finally we get here. And here I have to say thank you very much to Dennis, who is in this call, and it's called Chuen. How do you pronounce your nickname, Dennis? Is it Chunai, Svainai?
No, it's just if you say it in French, it means Denis, and that's my name.
Good. All right. He created a library that you can use with the board that we supplied in the kit, so that you can use it from your Arduino instead of the Python scripts that we had at the beginning. So this URL is important. I'm going to paste that in the chat so that you can start going there and getting that repository, cloning it and stuff. In the meantime, I'm going to show the wiring, which was very nicely diagrammed by Thomas today. I have the thing here also. I don't know if I can switch on the micro. Let me try this. So, yeah, okay. I'm not sure if this helps a lot. Going back to sharing. Okay, so this is the wiring diagram. You need to connect. It's best if you put it in the breadboard, like in the diagram by Thomas. You can also solder headers on the batch. That's also possible. And you need to connect ground. We don't connect power to the board, and this is because it doesn't really work if you supply power from here. So you need to plug it from your USB. So it kind of double powered, right? So you power the Arduino, and then you also need to power the board from external power supply. I remember when we were analyzing this board that it is possible to supply power from the microcontroller, but I think you need to cut some of the bridges that are somewhere. It's all documented, but it was a bit of a risky move. So we left it as it is. You can just put a micro USB thing to power it, and it will be fine. And then you have to connect the serial cables. This is transmission and reception, TX and RX. Always remember that what is RX in one board needs to connect to TX of the other board, and TX goes to RX, right? This is most common mistake ever. So the TX and RX TX and RX are here in the Arduino. So right next to the Nina module on the right, if you're looking in from above, and they connect like this. And then you need to connect additionally. So it's a serial interface, but it requires control flow. So you need to connect two digital pins, two for the command line and the BC line. So this is so that the protocol is more or less like, I'm going to talk to you. Are you ready? Yes, I'm ready. Okay, here it is. Okay, so that whole handshake happens every time you send something to the device. All right. Now there are 4 steps in order to use the board, kind of, let's say, properly. And I will get to the detail of why I say properly in a second. You first need to get the device ID or device EUI that has been assigned to your device. Your device comes with one. You can override it, but it's best if you use the one that it comes with the device. You take that, and then you can register the device on the Things network. And doing that will give you 2 more identifiers or 2 more keys. One is called app EUID, and the other one is called app key. You take those and you put those in your code, and then you can finally join the network with those. And once you're joined, then you can send as much as you want. There was a bit of a confusion at first because the keys are persistent on the device, but the join state is not. So you can set these keys once and they will stay there, but you need to join every time that the device turns on, which was, I misunderstood that as being, as retaining the joint state, but it doesn't. So these are the steps to connect. And let's go step by step. So I think I'm going to Okay. Second. Max is asking if it's possible to use it without the Arduino. Yes, the board, it's yeah, as Thomas is saying, the board is capable of running application code, but you would lose the current modem firmware. This is very important because maybe you don't realize it, but the firmware that we have in this board is almost like a world premiere. You know, Semtech gave this one to us as a very much bleeding edge development. Back in March, it was really I think no one had it, or very few, only the partners of Semtech. Right now, maybe some more people has this, but it's still very new and very powerful, as Anton explained on the kickoff. It has a lot of very sophisticated features. You are asking where can I load the firmware? I need to load it for you. This we cannot share for now because this is, as I just mentioned, this has not been publicly released yet. So I would need to flash or reflash the device for you. So maybe if you come to the lab tomorrow, we can fix it. It tells me that my gateway is not connected. Should I put the Ethernet cable into the blue gateway? You have to, the gateway needs to go, the cable in the gateway needs to go into the black connector. It is a bit slow to start, so give it a good 2-3 minutes to connect. Unfortunately, sometimes the web UI of the Things network shows that you are not connected, but you are. I cannot explain why this is. It's just very annoying. Okay, you put it in the Bluetooth slot. Okay, then that explains. If you connect it and it still says not connected, just try to ignore that and try to send messages, because maybe it works. Or contact me and then we can try to check. There's another way of checking the state of the gateway from a different URL that is not a nice UI, but it's one that doesn't have any caching, because sometimes the web UI kind of caches a state and then it looks like it's not connected when it actually is. Hopefully this won't happen, but it might. Okay. All right. Okay. So let's go step by step. Thomas is also pointing to the make Zurich hardware intro. So you can, if you go to the hardware intro that Thomas prepared, you can see the same diagram that I have in the slides, the same wiring details. You can also see this if you're really interested in knowing how the board works. this is the reference from Semtech of the modem. It's very extensive, but it's also pretty decent, pretty good. All right, and now we're going to make sure you clone this or you copy this, download this code, whatever you prefer to get this code. We are going to need the library that is in here. This is not yet an Arduino library because Dennis finished it today, and it's still work in progress actually, I guess. But it's very cool that this is available already. This is super awesome. So thanks again. And then we have a bunch of examples in here. So first we need to get the device EUID. Then we will, like step by step, we will do a join, and then we will send data. Also in the examples here, like step by step, the code. Just getting the information of your device is super simple. We wait for the serial to be ready, and then we say begin and then info, and it will print on the serial monitor the device that ID that we need. So let's do that first. I'm going to go here. What I did, I'm pretty sure there's a better way of doing this, but to make it easy for this test to run and yet being able to change the library, I just copied this. Sorry, this is, you don't know. I just copied these two files in source. I copied them into the examples so that they can be imported without being fully libraries. Okay. About the Miramico module that was asked in the chat. The Miramico module runs the same software modem in principle, so you can use the same code to connect to the Miramico model. We didn't test this, but it should be possible. Do I need to put in batteries? No. Where does it get the power from? From USB, yeah. Okay, Dennis is answering everything. Okay, with one usage, still link. Yeah, I think we should create a real Arduino library, but for hacking, this is perfect. So we will get one. We will build one as we move along. From Dennis is saying that from Platformio you can do more useful stuff, but from the Arduino IDE it's a bit limited. How these things can be done. Okay, let's try to connect. As I said, I will need to power both the device and the board. So if you see here, I have the two things powered. This one has a USB connection to any USB port, and then the Arduino is obviously also connected to USB. So I opened first the get device ID example. We don't need to touch these two files, and we just need to run it. Now there are a few quirks if you're on Windows, because Windows. The Arduino IDE doesn't handle very well the port in which this thing is, because it has two ports. So the best way to flash this thing multiple times is to press the reset twice. If you press the reset of the Arduino, if you press the reset button of the Arduino twice, the yellow LED will start blinking, and then it's in bootloader mode. That means that the port will have changed in Windows. It does it all the time. Now I have come port 15, and that means that I can also flash without failures. Usually, if you don't do that, you will flash and it will complain, and you need to switch manually and flash again. So it's super annoying. With this, you can just upload. If you use a real operating system, these things don't happen. But yeah. Okay, it's taking its time to compile. This, I'm not gonna blame it on Windows. I think this is just my computer that can barely cope with Zoom video. So asking it to compile while zooming is asking too much. Okay.
While it's compiling, I'll go ahead and ask a question with voice. Can you hear me well?
Yep.
Yeah. Okay. I was wondering, this LoRa modem library that Dennis has put together, is it specific to the Murata module, or is it specific to the soft modem firmware that is loaded on it?
It's specific to the soft modem, so it works with any other module that implements it. For instance,
Okay.
the Miramico one.
Okay, but it wouldn't work, for example, with the old modules that we used 2 years ago in the Make the Rig 2017.
No, because that one implements the same type of modem, but it's older. But it's also a serial modem.
Okay, thanks.
This is really taking forever. Are there more questions in the meantime? There we go. Yes. Good. Okay. It always lies that it's done in 3 seconds, but that's just the upload thing, right? Okay. If you're on Windows again, you will need to switch ports one more time. And you open the serial monitor on the left, sorry, on the right top corner. And it opens somewhere that I don't see. Here we are. So when it opens, you have this kind of info printed here. Okay, is because all the commands are working fine. And then you have the version status. This, for example, if you get a status 8, it means that the device is already joined. This can happen, for example, if you reset your Arduino, but you don't cut the power, or you don't reset the SD board. If they have different power supplies, they have different lifetimes. So if you reset the Arduino, you start talking to the modem, and it will still be joined. So if your code needs to handle that situation, you can check the status and then do something with it. And then we have 3 identifiers. One is called the chip ID. The chip ID is like hard coded into the chip itself. It's unique to the chip. You cannot change it. Then you have the dev EUI, which is the thing that we're looking for. It's this thing starting with this F, whatever. This thing can be replaced if you need, but it will by default be the same as the chip ID. Then we have an app UID, but this one is only set because I already set it before when I was playing. But out of the box, it will have some random numbers. I don't know which app ID that one is. And finally, the region 1 is the European 868 frequency.
Just a short remark here as well. It could be that it's not showing right thing at the beginning, that it shows some timeouts or whatever. And this can be because the connection somehow at the start gets lost between Arduino and the computer, and the solution is just to reset the Arduino, and then it should work.
Mm-hmm. Yeah, thanks. Okay, so once we have this number or this ID, we copy it from here. We go to the console of the Things network. Where do I have the window? So we go here, we say I want to register a new device. You can name your device with an ID that it's unique for the application, but this is just an identifier that you give to it. So whatever device. And then here it's where you paste the thing that you copied from the Arduino serial. You see that the application key will be generated, and the application EUI is because we have already created in the previous step the application, right? So if I say register, I already registered it, but if I say registered, I will come to this screen where you see something like this. Here you see a bunch of different identifiers. We are going to need these two now. So if I go back to the slides to put things in context. Sorry. So we did this part. We got the dev UID. we register the device on the Things network. Now we need to get app EUID and key from Ttn, and then we will put that into our code. Mhm. 1 second. All right, now let's go back here. So it generates a bunch of things, network session keys. These keys we never really see directly. But what it's important to highlight here is this. There are two ways to authenticate a sensor or a device to the network. We are going to use over-the-air authentication, which is shortened as OTAA, or and the alternative would be to use something called ABP, activation by personalization. It's really not recommendable to use ABP. It is a bit easier because then you hard code the keys, but for any not even serious development, for the simplest example that you want to keep running for a little bit, even if it's for maker purposes, I would say just always use over-the-air authentication, over-the-air activation. The difference is one is hard-coded and all the keys are there. And if you need to change the keys, you need to refresh the device. The other one, you have some set of keys that you have shared, but you can reprovision the device in another network if you want, for instance. And then the next time the device will join the new network. Yeah, it's just better and more secure. All right, so let's try the next example. I'm going to open the join example here. Good, so now we have a bit more code. The first part stays the same, begin and info, to print some stuff into the serial. But now we have these two keys that we need to take care of. And we see that they are used here to join the network. Then there's a waiting to make sure that we really wait on setup until it's joined. And we are not doing anything else in this example. So this only does joining. Now, where do we get these keys? We go to the console. And we need to get this key. But you'll see that this key is in a different format. We have here an int array, and this is a hexadecimal string. Luckily, we can switch the mode here, and we can get the right format. So we need these two things. We want them in this format. We want this to be also MSP, so most significant bit first. And then we just copy. So we copy the application UID first, we paste it here. We copy the app key, then paste it here. And we are ready to try again. So I'm gonna do again the double click on the Arduino to switch it to bootloader mode. Now I need to select the port once again, and I can upload it. Let's see if it takes forever again. Is it clear so far? Other questions while this thing up compiles? Are there questions about life, the universe, and everything else? I don't know the answers. Well, we know the answer, but
Yeah, I have a question again. Let's say we have, I don't know, 100 devices and we need somehow to configure them all. How do you know some kind of a process to do that quite efficiently?
No, I know that this can be done. And I know that people working professionally on this have figured out ways of doing this. I never had to do it, so I don't know really how this can be done.
Okay.
But the features in this modem would allow for things like that, for sure. The fact that keys are persistent, for instance, this thing that we were talking today, the keys are persistent, it is intended for this like pre-personalization and at factory scenario.
Yeah. Okay, thanks.
I think if you want to know more about this, how to mass update things, so how to mass personalize devices, besides getting in touch with the people from Semtech, I don't know if anyone of them is in this call. I think I haven't seen them. But either Diego or Anton might be able to help, but also Milomico developers. They definitely have done this, and then they can give you a hand. And since this is now asked again, how about the Milomico module? Is it also so easy to configure as this STM based? Yes, in principle, it's using the same code in the module, so it should behave the same. The big disclaimer is that we haven't tested it, but in principle, it should be identical. In theory, you should be able to replace the ST board with like rewire it to the Milomico module, and it should work. In practice, probably you need to tweak a few things, but basically it should be the same. Okay, so it finished compiling. I need to switch ports again. And then I can open the serial port and we see if it succeeded or if it succeeds in joining. So now I get all the information and then it's waiting here for the join to be successful, hopefully. I can check already in my gateway view. Okay, it joined. I can also see here in the traffic. Okay, I was not in this window, so I missed it. But if you are in the traffic window, you would see the traffic that authenticates this device. What I can see now, I think, is on devices. We see it, that we see that the status is seen 30 seconds ago because it just authenticated. And maybe we see this, yes. This is the activation. I'm not sure what this is. I think some whatever. But this is the authentication. It was activated. It got this device address assigned. Device addresses are assigned when you join the network. And then you have this metadata that's quite interesting. Now I live in Fork, so the only gateway around is the one I have right here. So that's the only gateway that got the signal. But if you are in downtown Zurich, you would see that this list of gateways that receive the message is much longer, and you have information of all of them. Another thing to see here is this, that data rate, SF7, this means spreading factor 7. There are a few ways of sending, basically how much time in the air, how spread through the airwaves the message is. If it's super short, it's very efficient. It sends in very little time, but it also goes, it doesn't go that far. if you send with the highest spreading factor, which is 12, it goes really far because it takes up a lot of airtime. So there's a lot of room for corrections and like missing stuff. So it can be picked up by gateways super far away. But on the other side, it will basically take up all your duty cycle. So you will not be able to send much if you use that. Technically, using hard-coded SF12 is forbidden on a public network. And the device will switch to it if it has to, but you cannot hard-code it to do it. Of course, as everything, you can actually hard-code it. It's just that you should not. Yeah, Dennis is pointing to an airtime calculator from the Things Network that allows you to see. If you say like if you have 40 bytes with spreading factors, are all the spreading factors available from 7 to 12 in Europe using this bandwidth, it would be 100 milliseconds on the air, but the same message with 12 takes 2.5 seconds basically on the air. So this will eat up all your time. Good. Okay, so we joined, but we haven't done anything with this. Wait, I need to have the kids with me today. Yeah, Dennis is correct. That was a fast join, in fact. Yeah. Exactly. If you have no gateways around, it takes longer. Good. All right. Let's try the last example. Let's try to send some data, and then we can go to bed. That's Oleg just said. I think Oleg, you were talking about the kids, right? But yeah. I lost the window. Where do I have it? Oh. So let's open the last example. So, okay, good. I need to copy the same keys. Okay. Process. Good. So the sending example is the same, but in the loop, we're going to send a message every 10 seconds. It's a message with 11 bytes. Yeah, that's it. So let's flash it. I have to do again the double press on the reset button to put it on bootloader mode. And then select the port again. And I'll upload it.
Here's a small comment as well. The modem join doesn't matter. If you're already joined, it won't do anything. So you can leave it or remove it. Doesn't matter. And it won't rejoin.
Yeah, you need to leave the network, right? Before you rejoin.
Yes.
Yeah. But if you power cycle the modem, then you need to rejoin it.
Yeah.
So this is important when you're debugging this. We're flashing it. We're flashing the Arduino, and the Arduino is reset every time we do that. But the modem is not. So to really have a fresh start, you need to press the reset button on the SD board as well. So I'm gonna do this while this is loading, compiling and uploading, so that we should have a clean join again.
Quick question then, why does the join take so long? I would have thought that if your router or your gateway is right next to you, the latency would be very short, and it's connected to an internet, which is latency also very short. What's the defining time constraint?
I'm not completely sure. The device needs to wait for a receive window once, so it sends a join request, then it goes to sleep. It wakes up. I don't remember exactly when.
5 seconds.
5 seconds.
Yeah.
Oh, okay. Yeah, that explains a lot of the time delay then.
Maybe if you want to know, there's a specific handling how they do that. It starts, for example, with SF7 and tries, and so it sends a request to join and wait 5 seconds. If it gets an answer, then it's fine. If for some reason it doesn't get an answer, it will go to sleep for a certain time, probably like between 15 seconds and some minutes. And then it will try with SF8, do the same again, and so on. And it will extend the data rate more and more until it gets a connection. And if you're far away, this could take up to multiple minutes. And that's why it takes so long at the end, because it looks that it doesn't send requests directly after a failed one to save the whole network, or not to populate it too much.
Yeah. Good. So we have flashed the thing. Now I need to change ports again and open the serial monitor. We see again it's waiting. Okay, now it's joined rather very quick. And it will start sending once every 10 seconds. And then, yeah, we have a message. Good. So it sends. It will send another one every 10 seconds. There we have a second one. And yes, we have data. Now we are connected to the Things network finally. I'll leave it as an exercise because it's already 10. I'll leave it as an exercise to you to figure out what this payload means. There are some resources that I can point you to. So there's a nice write-up about how to work with bytes in the Things network documentation. You should, as I say, you should kind of optimize your payload. There is something very interesting about working with that kind of things on a higher level. So when you go here, I'll just touch upon this topic, but I will not go into the details. But the application, sorry, in the application level, you can define payload formats. And then you can have converters, decoders, and encoders. The decoders are perhaps the more relevant bits. Is you can write a bit of JavaScript that takes the raw byte array, the one that we that we see, that we just saw basically. If I go to, so it takes this payload, and you can run the decoding. So you can do something with it to turn it into an object, like a JavaScript object, and it is that thing that will be passed down to your applications. If you were in the workshop on Saturday by Peter Affelden, he showed like all this side of the connection, in which you take the data from here, and what can you do with it? You can do a lot of things. From doing the decoding here, that will save you some time down the road, because you get the data ready, converted into something that it's application. It's logical, not just like raw binary data. To installing integrations, you can set integrations with if this and that, for instance, or HTTP integration. There's a specific Ttn Mapper integration. Some of these tools like Cayenne and whatnot. There's a data storage service also. But if you just want to get the data, you can connect to via MQTT, for instance. There are lots of clients, or so you can connect to MQTT, and then you get the data in JSON format with all the metadata for gateways that received it and whatnot. Thomas is suggesting ThinkSpeak as well as a service. We get to command join event errors. I would say try again. Yeah, this is. If you're interested in just. Yep. Dennis is pointing that if you keep this page open, you will see this request coming in. Well, now I lost them, but yeah, they were here. You also see stuff in your gateway page, in the traffic page, that might indicate, for instance, when testing, I forgot multiple times to update the key properly, or I copied the wrong keys. If you do that, then you will see traffic in the request in the traffic tab of the gateway, but nothing in the device. Yeah, but then once you have the data going through the thing, you can either get it via MQTT directly. This is like the most direct way to get it, or you can use any of the many libraries that are available. Like Node.js is a nice one. It says it's been discontinued. It's not recommended to use this SDK. Don't use this SDK. Nice. They say that they're all discontinued. Okay. Go is the only one recommended. No, but these things still work. I don't know why they say this. Probably because they want to migrate to V3 soon, so they're suggesting people not to use it. But yeah, this is easy to get the data or use MQTT directly. And with that, I would say we are done for the day. If you're interested into the even deeper technical details of LoRa, there's another crash course called Crash Course, not LoRaWAN, by Thomas Kaplan or something like that I cannot pronounce very well. He's a radio expert and part of the original team that developed the Things Network. It's a really worth the watch. It's full of technical details, but it's also explained very easily. So it's nice to watch. And yeah, thank you very much. And I'll say, like, if you have questions, this is the time